Been asked to have a go through 2013 NCEA question 2. So with this, we're looking at probability distribution using a normal distribution curve. All right, so it's got all this information here, and most of it's completely irrelevant. This is the bit we want to know. So the blood pressure of students at a school where Alice is a nurse is approximately normally distributed, and so that's the first thing we're going to do. So I'm just going to draw a normal distribution curve of some sort. Here we go. They don't give us much room for drawing these things, but there it is. And we're told normally distributed mean, I'll draw mean here, is going to be 113 Hg, whatever Hg is. And standard deviation, draw a little sigma here, is going to be 10.3. And these are all milligrams. Oh, sorry, that's milligrams per. So I'll get that right. So milligrams Hg. Okay, so that's milligrams of mercury, is it? All right, so this is going to be milligrams of mercury, millimeters. Sorry, millimeters of mercury. In other words, that must be the height of the mercury in the thermometer. All right. And it says what proportion of the students chosen at random from Alice's school would be expected to have blood pressures between 113, which of course is the mean, which is there, and 120. Let's say 120 is there. So that's my 120 mark. So we're trying to find this here. So we've got a number of ways of doing this. I think I'm just going to use the calculator to do it. So let's go ahead and just do that. So I'm going to choose this thing here, and I'm going to say menu. I'm going to go to 2 for stats. I'm going to hit distribution. I'm going to go norm, and I'm going to go NCD. All right, so this is just something from last time. So the lower is going to be 113, which is also the mean. The upper is going to be 120. The standard deviation we decided was 10.3, and the mean is going to be also 113. Now, for the exam, as I understand it, it's perfectly okay to use a calculator for this. You don't need to not do that. So I'm going to go down, I'm going to go calc, and I'm going to end up with the p-value of 0.25162. I think having it to 4 dPs here is probably appropriate. So I'm just going to write here, so I can see it actually. So I have to write it correctly here. So you want to write the P that Z is going to be between, and I wonder if we should say the Z value. Right, okay, we'll put the Z value in. So Z is going to be greater than the mean, which is a 0 value of Z. In other words, nothing for distance from the mean. And you've got 0.6796, which is what 120 is. And that's going to be equal to, and I'm just taking this straight off the screen here, folks. So here's my 0, here's my upper limit, and I've got 0.2516 is going to be 0.2516. And that is the probability thereafter.